Welcome to today's lesson. Today we will be able to solve a quadratic function using the quadratic formula. We will be able to explain how we find the solutions to a quadratic function. So let's take a look at today's do now. We want to solve the given quadratic. So I'm going to let you guys do your distributions, combine like terms, factor, and solve your equation. Alright, so let's look at what we have here. So I distributed and then I moved everything to the left so I could have it set equal to 0. I tried to do my AC method, but AC method did not work. There was no way I can find two numbers that multiply to -2 and add up to a -8. So since I cannot factor, that means I have to do a different type of method, which I did complete the square method. In complete the square method, we don't like an A term, so I changed it. I started doing my vertex form, and then I divided everything by 2. I changed my form into vertex form, which gives me this piece here. From there, I started solving for x, moving that 9 over, dividing by 2, square rooting, positive and negative, right? So the square root of 9 over 2 is the square root of 9. So here, if I were to separate this, square root of 9, square root of 2, which gave me that 3 over rad 2. Since we don't like radicals in the bottom, I multiplied both top and bottom by radical 2, giving me my final answer of x equals to plus or minus 3 rad 2 over 2. So this actually will conclude all the forms or ways you can solve a quadratic function. So how do we find the solutions to a quadratic function? Solutions to a quadratic function: the x-intercept when y equals 0 of a quadratic function are the solutions to the related quadratic equation. You can find the solutions of a quadratic function or quadratic by graphically looking at the roots, by applying some sort of factoring, basic factoring or AC method factoring. If you cannot factor, completing the square would be your option, but you can also use the quadratic formula. So we are going to use the quadratic formula in today's lesson. We are going to do x equals -b plus or minus the square root of b squared minus 4ac all over 2a, where a does not equal 0. This formula is found in your formula booklet, so you don't need to memorize it, but I'm pretty sure a lot of you guys already have. Question 1 says find the zeros of the following. F of x is equal to 2x squared minus 4x minus 3. In order for us to use the quadratic formula, we are going to need to identify our a, our b, and our c values. So here I have a is equal to 2, b is equal to -4, and c is equal to -3. This is a non-calculator question, which is important when we are doing our work. So first thing I'm going to do is I'm going to write down my formula just so everything is in front of me. And I am going to start substituting. At this point, I'm going to slowly start simplifying everything I can. And let's simplify what's under the radical if I add that. All right, so at this point, I have the square root of 40, which I know can be broken down further. I'm going to actually simplify further here. Two numbers that will multiply to 40, one of which is a perfect square, would be 4 and 10. And let's keep going. Let's keep simplifying. I have 4 divide 4. And I have plus or minus 2 rad 10 divided by 4. Each of these pieces are going to be divided by that denominator 4, which we get a simplified final answer of x equals 1 plus or minus rad 10 over 2, right? I actually made a mistake before. I had to go back. It was divided by 4, not divided by 2. So I'm simplifying 2 over 4, giving me a 1/2. And that rad 10 stays in the top. So this would be my final simplified version. Let's look at number 2. For number 2, it says, let f of x equal 4x squared minus 4x minus 5 and g of x equal 8x plus 6. Find the x coordinate where f of x and g of x intersect. B, sketch the graphs of f of x and g of x. Okay, so we're actually only going to do part A here. We're not going to sketch the graph because it is a non-calculated question, and where they intersect is not going to be a nice point. So let's just find the x coordinates where f of x and g of x intersect. When two functions intersect, what that means is that both functions are set equal to each other. They're crossing and they're meeting at some point. So what we're going to do is set f of x equal to g of x. I'm going to solve for x by setting this quadratic equal to 0. I'm going to identify my a, my b, and my c term. And I'm going to use my quadratic formula. Okay, so let's plug in everything we know. We're going to simplify this. Again, I'm going to combine what's under the radical and see if I can go ahead and simplify further. 320 can be divided by 64. This is a number that's also very popular, so I tend to remember some of these. 320 can be divided by 64, which would be my factor. 12 plus or minus square root of 64 times square root of 5 all over 8, which I am going to keep going and simplifying further. And again, I'm dividing each of these pieces by my 8, by that denominator. So I'm going to separate it if I need to, or just know that. And we get our final answer of 3/2 plus or minus radical 5. And we are not doing the sketch of the graphs. Last one. All right, let's look at this question here. Let f of x equal 9x squared minus 12x plus 2. Consider the graph of y equals f of x. The x-intercept of the graphs are a comma 0 and b comma 0, where a is less than or equal to x, which is less than or equal to b. Find the value of a and b. Okay, so what is this? We have a graph of f of x, and we intersect the x-axis, right? That's what this piece here is telling me, at these two specific points. So let me just visualize what is happening. We have a graph of f of x, which let's say something like this, positive a x squared. So I have intersects here and intersects here. Those are the x-intercepts. So I have some point a comma 0, some point b comma 0, where x is somewhere in between a and b. Okay. So we want to find these actual points. The x-intercepts are the solutions, or also the roots of your function. So the easiest way to do this is for us to use, whether we factor, complete the square or quadratic formula to go ahead and find these points. Now, A, you must know, is the smaller value, and B is going to be my larger value. So when I identify these pieces, I must put it in that specific order. So I am going to go ahead and use quadratic formula for this specific problem. So again, write down my formula. We have our function, we have our A, our B, and our C values there. I'm going to plug in, simplify, and get to my final destination. All right, so here's my final answer so far. We have x equals, you could either write it as separated fractions or one entire fraction as 1, just because the denominators are the same. So I am going to just represent my answer like this one. 2 plus or minus square root of 2 all over 3. So what is the value of A? Again, the value of A is the smaller value. So A in this case would be you taking 2, subtracting rad 2, dividing that by 3. And to get your larger value, B, you would take 2, add rad 2, divide by 3. Those are your x-intercepts. They didn't specify to write it as ordered pairs, so I'm just leaving my answer as that. But definitely identifying what A is and what B is, the smaller and the larger value. And that is all for today's lesson. So keep learning, keep growing, and I will see you in our next video.